Good morning, students. So today I am going to discuss the doubts of miscellaneous exercise chapter 3. So we are taking question number first. Let a equals to 0 1 0 0. Then we have to show that ai plus ba to the whole power n equals to a to the power n into I plus n a to the power n minus 1 into b into a, where this matrix I is given as I is identity matrix. Identity matrix, right? So the matrix involving the letter I stands for identity matrix, and wherever the capital A is coming, capital A is given as 0 1 0 0, this matrix. So first of all we will simplify this left hand side and right hand side. After that we will prove this LHS equal to RHS, right? And make sure whenever the any equation like n is containing, and we have to prove that this side equal to that side, so we will use principle of mathematical induction, because it is given that n is what, the natural number. Okay, so let's simplify the left hand side. Ai plus ba to the whole power n. Now I, that is identity matrix of order 2. Now write b as it is. The matrix A is given here 0 1 0 0. So substitute the value of A matrix and the whole power n. Okay, now on multiplying this A with this matrix, so A 0 0 A will come, plus multiply this constant B into this matrix, so we will get 0 0 0 as it is, and B into 1 is equals to B and the whole power n. Now adding, because they are of same order, so we can add A, then 0 plus B, B 0 0 0, and A plus 0 equals to A. So this becomes equation first. It means this is the left hand side, right? I mean this side has been solved in a simplest way of this. Now we have to simplify this side RHS. This is the right hand side. So what we will do, we will put the value of this identity matrix of order 2, A to the power n as it is, this term as it is till B, and this capital A will be replaced by this given matrix, right? So substitute the value of I and A at their respective places. So what we will get, see, RHS A to the power n, this is the value of I matrix, remaining term and matrix capital A. Now simplifying this, multiplying with A to the power n, we will get this 0 0 as it is, plus now the whole term 0 0 as it is, and 1 into the whole term as whole term. Okay, now adding these matrix, as we know that they are of same order, so we can add corresponding elements. So 0 plus this is this, 0 plus 0 0, 0 plus whole term remaining as it is, a to the power n plus 0 is a to the power n. So let's assume this is equation second. So now by writing LHS and LHS together, so we have to show that this is the LHS, that is equation first, what we have solved here. See, this is equation first, and the equation second is this. So LHS equal to RHS. Now the question basically starts at this phase. So we have to prove this whole matrix containing power n equal to this. So we will use the principle of mathematical induction. As I told, whenever the matrix involving small n, as there is question number 2 also and some other questions, so we have to go for multiplication, this mathematical induction method, right? So we know that mathematical induction containing 3 steps. So what is the first step? We put n equals to 1 and we will check whether result is true or not. So substitute at the place of n as 1. So you put here 1. So a b 0a to the power 1, see, equals to a to the power n, means a to the power 1 1 a to the power 1 minus 1 into b a to the power 1 or 0 as it is. So we have put n equals to 1 on both the sides. So here power 1 means the same matrix, and simplifying this we will get ab 0a. So what we find? We can conclude that LHS equal to RHS. So hence the result mathematical statement we can assume n, P n is true for n equals to 1. Okay, now we go for second step. What is the second step? We assume that Pn is true for n equals to k, where k is what? Any arbitrary natural number. This is the rule, principle of mathematical induction. So what we have done in this step, in the previous equation, just put in place of n as k. Wherever n was coming, so write k everywhere, right, in the previous equations. Now step third, we shall show that, you can mark this is step second and third. We shall prove that this mathematical result is true for n equals to k plus 1 whenever p of k is true. P of k means this equation, whenever this equation step second is true, right? So class 11th we had learned this method, so we are using that. So now in step third we will replace this k by k plus 1. I hope you remember k by k plus 1, and similarly the RHS, wherever k coming we will write k plus 1, k plus 1, k plus 1, k plus 1. I mean everywhere we have to put k equals to k plus 1, right? So it means we have to prove this LHS equals to this whenever step second is true. So we will consider LHS left hand side, that is this side we will take, okay, and using this step we will be finally arriving at this step. I mean we will prove that this side equal to this side, and hence the result is obtained. Okay, so let's take this side AB0A to the power k plus 1. I mean left hand side we are taking. So taking left hand side AB0A to the power k plus 1. Now we will use exponent law. So this power k plus 1 can be written as k into, you can say 1, because if the base is same then power is what? K plus 1. And now using step second AB0A to the power k, this is the value. You can see the previous equation. The value of this k equals to this term, and AB0A as it is. So using Pn is true for n equals to k, that is equation first. Okay, we have used equation first, that is value of this whole matrix equal to this. Now you can see in equation first. Now we will go for matrix multiplication, row by column. So a to the power k into a, we already learned this matrix multiplication. This element will be multiplied with this, so this will come, and similarly this second element multiplied by this. Always you multiply row by column. So 0 into whole term equals to 0 plus this a to the power k plus 1 comes. Now a to the power k into b, okay, plus the whole term into a. So this is coming. See, a to the power k minus 1 or a. So I have used a to the power k plus 1 and k plus 1 minus 1. That is this k minus 1 and power is 1. So k minus 1 plus 1. There 1 or 1 cancel out. We can also simplify. Similarly, second row and first column. So a into 0 plus 0 into this. So 0 will come. Now 0 into b, that is 0 plus a to the power k into a, means a to the power k plus 1. We are using here exponent property, exponent law. Now we can take a to the power k common in both terms. So we will get b plus b into k, and the a to the power k plus 1 as it is 0. Now this will be equals to, we can further take b common, so we will get k plus 1 into b into this. Now what we see, this is exactly this step second right hand side. You can see this step and that step is same. So this is what actually we were looking to prove, that this side will be equal to this using step second. So hence by using principle of mathematical induction, the result is true for all the natural number, hence the question is proved. Alright, so this is the problem number first. Now I am taking question number 10 as you asked. Question number 10. So this is the important problem, numerical problem, practically problem based. So according to question, this matrix is given, matrix A, 10,000, 2,000 and this. Okay, order is what? 2 by 3. So this matrix is already given in the question. and this matrix is against the two market. So this row indicates market first and second row indicates market second, right? So now there are two parts. So in the first part, let B be the matrix, column matrix representing the sale price of each unit. So this sale price of each unit is given, right? But what we have done, we have converted into column matrix. Why? Because we want to find revenue, and revenue is what? The product of this commodity into this sale price of each unit. So we have to multiply in this question two matrices, and we know that the product of two matrices is only defined if the number of column of this matrix equals to number of rows of first matrix, right? So if you design this sale price matrix in row form, then the order will be 1 by 3, 1 by 3. Then the column will not be equal to number of rows. So that's why we have to design here column matrix, right? We have also done same type of questions in the previous exercise, right? So here it is important to consider column matrix, right? So order is 3 by 1. Now the product of matrices is possible. So we have to find revenue. Revenue is what? Sale price matrix into number of items sold. That is number of items sold. This is the matrix and this is the sale price. So let us find the product. We know that row by column. This is the row and the column. So 10,000 into this 2.5, 25,000 plus 2,000 into 1.5, 3,000 plus 18,000 into 1. Similarly, multiply this second row by first column. You will get, after adding this, we will get 46,000 and second row gives 53,000. Addition of these entries will be 53,000. So now, therefore, revenue collected by sale of all items in the market first. This is showing what? Market first, and this is the amount scoring by market second, right? So this is what the total revenue obtained by each market, 46,000 and 53,000. So this is the answer in first part. Now see, similarly the B part, again we are given the cost price. In the previous part we were given sale matrix, sale price, so which we converted into column matrix. Same as part first, we have to design again column matrix. So now this time we have to find total cost. That is the product of given matrix connected to the given markets, same matrix, and C is the denoting cost price, right, of the product. So multiplying this, we will get against the market 31,000 and 36,000. This is against the market first and this is against the market second. Now we have to find profit. So profit collected by two markets equals to profit matrix. That is profit. We are going to collect profit with these two markets. So this is given by, there is a formula, revenue minus cost price. So revenue we have obtained in the first part and the cost price is what? This is the cost price. So we have to find the difference of these two matrices. Difference of the first part and second part. So what we find? Difference 15,000 and 17,000. That is, we can subtract these matrices directly because they are of same order. So therefore the gross profit, okay, and the previously we have calculated profit only, right? Now this is what? Gross profit. So in both the markets, this is what the sum of these amount 15,000 plus 17,000 is the gross profit. That is total profit. Okay. So by adding these markets amount, we'll get 32,000, and this is the answer. Okay. So this was the query number 10. Now you asked question number 12, right? So see, in this part we are given there are two matrices A and B of same order and they are square matrices. So square matrices and same order, and this is also given, they are defined as A into B equals to B into A. Equation first, let's assume this is given, and we have to prove that AB to the power n equals to B to the power n into A. This is what we have to prove. Okay, AB equal to B is given, make sure, or AB to the power n equal to B to the power n A we have to prove. So as the result involving the n means natural number, so we will again using what? This is principle of mathematical induction. So step first, put n equal to 1 on both of the sides. So AB to the power 1, B to the power 1 into A, that is AB equals to BA, and this result AB equal to BA is already given in the question. So hence the step first is true, that is the mathematical result is true for n equals to 1. Now in step second, we assume the result is true for n equals to k, where k is what? Any arbitrary natural number. It means AB to the power k equal to B to the power k into A. So replace what? Nn is given in the question. So we have to replace n by k in LHS and RHS. In the last step, we shall show that the same result is true for k plus 1 whenever this result second, this is as first, this result second is true. So let's put k as k plus 1 on both of these sides. A B to the power k plus 1 equal to B to the power k plus 1 into A. This is what we have to prove. So we will take what? This left hand side. So taking left hand side, and we have to get right hand side. So take left hand side, A B to the power k plus 1. This is the left hand side. Now we can use exponent law. B to the power k plus 1 can be expressed as B to the power k into B. Okay. And now this A B to the power k is given what? Using step second. What is the step second? That is equation second. A B to the power k equal to B to the power k into A. So in place of A B to the power k, we will have to write B to the power k into A using step second, because that is assumed as true, into B as it is. Now associative property also hold of same matrices, that is square matrices of same order, right? So we can apply here associative property. So there are 1, 2, 3 matrices. Okay, so associative property states that any two matrices can be taken together in product. So B to the power k as it is, and this A or B is taken together, because A is in a product of this with B to the power k. Now we are taking, due to this property, A into B separately. This is the important step. And further, this AB equals to what? BA as given. This is already given in equation first. You can check AB equals to BA. So this AB equal to BA has come now. And again using associative property. So B to the power k into B. This B is taken with this matrix, and this A is written separately as per associative law. Now using exponent law, B to the power k plus, this is 1. So k plus 1 into A. So what we see, now check the right hand side. B to the power k plus 1 into A we have obtained. So these are the very important properties which has been used. So you have to write against each and every step. This is even more important in solving the question. Do not write these steps directly. Okay. Same as in the next part, in the same question further, we have to prove that AB to the power n equals to A to the power n into B to the power n for all n belongs to n. So again we are using all those three steps, that is principle of mathematical induction. Step 1, n equals to 1. So putting n equals to 1 on both the sides. So what we see, AB equals to AB. Clearly the product of two matrices is the same as A into B. Now assume for k. So putting k. Now in step third, we will put n equals to k plus 1. So replace this k by k plus 1. Right? So we'll get AB to the power k plus 1, and then RHS k plus 1, k plus 1. So now let's take LHS, right? AB to the power k plus 1. Now using again exponent law. So AB to the power k into AB, right? Now using step first, second, AB to the power k equal to what? Check. ab to the power k equals to a to the power k into b to the power k. So we are using equation second because this is true as in step second, right? ab to the power k equal to written as this a to the power k into b to the power k. Now the same value, this ab is what? This is given ab equals to ba, or you can say using equation first, right? This is ab equal to ba, equation first, not this in part first we have proved. Okay, you can see this is given in first part, ab equal to ba, so we can use that property also over here because this is what the same questions, right? So same conditions will be applicable. So in place of ab we are writing ba as part first, we have proved it and this is already given. So now again using associative property, so see what we are doing, a to the power k as it is into b to the power k or b we are writing together because they are of same term as per associative property, and a is written here, right? And this can be written as b to the power k plus 1 into a, again due to associative property this a to the power k into a can be written together into b to the power k plus 1, and this will be a to the power k plus 1 into b to the power k plus 1, right? A to the power k plus 1 into b to the power k plus 1. So now check the result is what? Step third, this LHS and we have got, see, RHS, a to the power k plus 1 and b to the power k plus 1, right? Hence proved. So by using principle of mathematical induction we can prove that this result equal to that result. So I hope your all doubts are cleared from this exercise, and next videos I will be discussing about determinants. So you have to complete the miscellaneous exercise including example up to this exercise. Thank you very much.